Hello students, and welcome to this video on the Law of Cosines. During this video, you will need to have your geometry notebook open, and you can write the title at the top of one of your notebook pages, 8.6, the Law of Cosines. After you watch this video and do the exercises in this video, I will ask you to take a picture of the notes that you took and submit that picture onto Canvas. Let's get started. Learning the law of cosines is going to help you to be able to solve for some missing pieces in a triangle. Earlier this chapter, we focused on right triangles, and you learned how to find some missing side lengths and some missing angle measures in right triangles by using the Pythagorean theorem, by using the triangle angle sum theorem to find a missing angle if you know two of the angles. And then we also learned about sine, cosine, and tangent ratios that can help you to find some of these missing pieces in a right triangle. Right before spring break, we learned the law of sines, which helps you to find some missing pieces of information in any triangle. Not necessarily a right triangle. It could be acute, it could be obtuse, it could be any triangle, not limited to just right triangles. So the law of cosines is very similar to the law of sines in that it applies to any triangle. So it's not just for right triangles, and it will help you to find either a missing side length or a missing angle measure in a triangle. Now, don't get overwhelmed when I show you the formula. It is kind of a long formula, but once you memorize it and use it, it's really not as complicated as it looks at first. So I'm going to go ahead and show you guys the formula. All right, there it is. So this is one formula, but they wrote it three different ways, but you don't have to memorize all three things. If you just memorize one of them, then they're all the same thing. So you can write down in your notes this first one here. A squared equals b squared plus c squared minus 2 times b times c times the cosine of a. And of course you'll need to draw the triangle as well so that you know what it's talking about. So this is the law of cosines, and using the law of cosines will allow you to solve for either a missing side length or a missing angle measure in a triangle. Now, some of you guys are thinking, okay, where in the world did this formula come from? It's big, it's complicated, how do we even get the formula? Well, if you are curious about that, there's actually a very exciting proof that you can do on page 595 in your textbook, and it's number 46, and this proof here will actually prove the law of cosines for you. If you want to fill in some of these reasons here, the statement kind of walks you through how we get the law of cosines, where it comes from. We already walked through the proof of the law of sines together, so we're going to go ahead and skip the proof of the law of cosines. But again, if you're curious about where this big long formula came from, go ahead and take another look at number 46 on page 595 in your textbook, and it will give you a little bit more of an insight into where the law of cosines comes from. One other thing you might be thinking about the law of cosines is, wait a minute, if we already learned the law of sines, and if the law of sines is already going to help us figure out some missing pieces in a triangle that's not necessarily a right triangle, but just any triangle, if we already learned the law of sines, then why do we need to know the law of cosines too? So let's talk about that for a second. Why can you not use the law of sines on any given triangle, given any information? Why do we need the law of cosines? Well, here's why. Let's say that we have a triangle, and we're trying to use the law of sines on the triangle. And let's say that we know what C is equal to, we know what angle C is equal to, and we know what A is, and we're trying to figure out what the measure of angle A is. Would we be able to use the law of sines to figure that out? Yes, definitely. That's actually a perfect setup for using the law of sines. If you know one angle and one side that's across from each other, and you know either another angle or another side, and you're solving for one of the other missing pieces, that's a perfect situation where you can use the law of sines. What if I was given the side C and the angle C, and I was given the side A, and I wanted to actually find out what the angle measure of B is? Would I be able to use the law of sines in that case? Yeah, I definitely would. I could just use the law of sines like I was already planning to before, and I could find out what this angle A is over here. And then I could use the triangle angle sum theorem to figure out the measure of angle B. So in both of those situations, I could use the law of sines, perfect examples. What would be a situation where maybe I could not use the law of sines? What if I was given the side length C and the side length A and the angle measure B? If I was given these three pieces of information here and I wanted to solve for anything else really, if I wanted, well, yeah, I couldn't do B. If I wanted to solve for B, if I wanted to solve for the measure of angle C, if I wanted to solve for the measure of angle A, is there any possible situation that I could somehow set up these three pieces of given information using the law of sines in order to find out any of those missing pieces of information? There's not, because in order to use the law of sines, you have to have at least one pair of opposite side and opposite angle. So if I had B and B, I could use the law of sines. Or if I had A and A, or if I had C and C. But since I don't have any pairs of opposite sides and opposite angles, I cannot use the law of sines to solve for anything else in this triangle based off of being given those three pieces of information. However, if I use the law of cosines, I can. So that's why we need the law of cosines, because if you have a triangle and if you are given these three pieces of information right here, you have to be able to somehow solve and find out what the other missing pieces of information in the triangle are. And you can't use the law of sines to do it. And since it's not necessarily a right triangle, you can't use the Pythagorean theorem, you can't use just sine, cosine, and tangent ratios. There has to be some other way to do it. And there is. That other way is the law of cosines. So today we are going to learn the law of cosines, and we're going to do some example problems using the law of cosines in order to solve for some of these missing pieces of information. The law of cosines is something that you're going to have to memorize eventually. For today, make sure that you have this written down at the top of your notebook so that as we're doing some of these example problems, you have it there to refer to. So let's do the first example problem together. We have example 3 to look at together. We're trying to find x, and this is the triangle that we have. We don't know what type of triangle it is. We don't know if it's acute or right or obtuse. And so looking at this triangle here, I can see that I'm given two side lengths and I'm given an angle measure, and I'm not given any pairs of opposite sides and opposite angles. So therefore I can't use the law of sines. I have to use the law of cosines in order to solve this problem. So let's see what that would look like. What would it look like if we tried to use the law of cosines to solve for x in this problem? As I'm writing this here in the video, go ahead and copy this down into your notes. So first you'll need to draw the picture of the triangle in your notes. Again, make sure that you have the law of cosines written down in your notes. And we're going to use the law of cosines right now. We're going to say, should it be x squared equals 9 squared equals or 11 squared equals? How do I know which side is the A? Well, looking at my formula here, I'm noticing that it says a squared and then it says cosine of A. So that tells me that the side that is squared and then it has an equal, that has to be paired with, that has to be matched with the opposite angle that we either are given or are trying to solve for. So here in my law of cosines, I have an a squared equals, and I have a cosine of a. And so if you either have or are trying to solve for an angle or a side, that's what you're going to have to use as the a squared or as the cosine of a. So in this case, the a squared is actually going to be x squared. So we're going to say x squared equals 9 squared plus 11 squared minus 2 times 9 times 11 times the cosine of 28 degrees. Okay, so let's talk about just one more time how I figured out which pieces of information to substitute into that equation. So for the A, the B, and the C, those are the three different sides. The only part of the formula that's an angle measure is the part where it says cosine of A. So the 28 degrees, I know that's going to have to be the cosine of A. That's the only angle measure that we have here. So the A, the B, and the C, those are going to be the three sides. And for the B and the C, it doesn't matter which one is which, but for the A, it does matter. I knew that the A needed to be the x in this problem because the x is across from the 28 degrees. All right, now that I figured out how to substitute the information into the formula, I'm going to continue to solve it step by step until we find out what x is equal to. So let's rewrite this and solve a little bit of it at a time. I'm going to say x squared equals 81 plus 121 minus, I'm going to do this part in my calculator. I'm going to type in 2 times 9 times 11 times the cosine of 28. And when I type all of that in, I get 174.8. If you did not get 174.8, make sure that your calculator is in degrees. It can't be in radians or you'll get a different answer. So again, make sure your calculator is in degrees. All right, I'm going to continue to solve this. According to PEMDAS, I have to do addition and subtraction from left to right. So this is going to be x squared is equal to, then I'm going to add the 121 plus 81, and I get 202. And then I'm going to subtract 174.8, and I get 27.2. So x squared is 27.2. We're solving for x, so we have to take the square root of both sides. So x is going to equal the square root of 27.2, which is 5.2. And that is our final answer. The problem said find x. X is equal to 5.2. I'm going to just double check and make sure that my answer makes sense. I'm going to look at the picture. Yeah, x was a side length, and I can see that the other side lengths are 9 and 11, so getting an answer of 5.2, that makes sense. I'm going to ask you guys to make sure that you have this written down in your notes. If you didn't have a chance to write it down yet, go ahead and do that now. And then I have one problem for you to try. And I am going to show you the answer after you're done with the problem, and I'm going to explain how to get the answer, but I want you to try it on your own. So if you don't feel like you're ready to try a problem on your own yet, go ahead and rewind the video 1 or 2 minutes, rewatch this part where we figured out how to find out what x is, because in the next problem, you're going to be doing the same thing. All right, it's your turn. This is the problem for you to try. In this problem, you're trying to solve for x. Please pause the video and give yourself as much time as you need in order to solve this problem. The answer to that problem is 30.2. If you got 30.2, go ahead and skip ahead in the video about 1 minute. If you did not get 30.2, let's talk about how we can get that answer. In order to get 30.2, go ahead and look at this first step here where I substituted in my information into the Law of Cosines formula. You can double check your work and see if you substituted the numbers into these same places that I did. The next step is to simplify. The 15 plus 19 squared, that is the same thing as 586. And then we have a minus sign. And then this next part here, the 2 times 15 times 19 times the cosine 125, that's actually equal to a negative number. It equals negative 326.94. Again, if you didn't get that answer, check your calculator and make sure that you're in degrees, not in radians. Subtracting a negative really means that you're adding a positive. 586 plus 326.94 equals 912.94. Then you can take the square root of both sides, and we get 30.2. All right, let's do one more example problem together. It's still the same formula, still the law of cosines, so nothing has changed in our formula. The only thing that's going to be a little different in this example problem is that instead of solving for a missing side length, we're solving for a missing angle measure. Same formula, we're going to substitute the numbers in the same way, but it's just going to look slightly different. So let's take a look at example 4 and figure out how we can solve for x. Again, notice in this problem that the x is an angle measure. According to the law of cosines, I only have one little spot right here where it says cosine of A. That's the only place in my formula where I see an angle measure. So I know that instead of cosine of A, in this problem, it's actually going to be the cosine of x. And remember, the a squared and the cosine of A, those are connected to each other. That has to be the side and the angle that are across from each other. So if I know that it's going to say cosine of x, the side that's going to be the a squared has to be across from this angle. So which side is across from x degrees? It's going to be the 8. Since the 8 is across from the x, I know that it has to be 8 squared equals, and then again, b and c doesn't matter which one. So 3 squared plus 6 squared minus 2 times 3 times 6 times the cosine of x. Now before I continue to solve this, just want to emphasize one thing really quickly. The way that I knew that the 8 squared had to be right here is because I know that the a squared is connected to the cosine of A. Those always have to be across from each other. So since I knew that I was solving to find out the x squared, the 8 is across from the x squared. That's how I knew that it should be 8 squared equals, and then everything else. All right, let's go ahead and continue to solve this. So I'm going to simplify this. It's going to be 64 equals 9 plus 36 minus 2 times 3 is 6. 6 times 6 is 36. So minus 36 times the cosine of x. Let's see, 9 plus 36, that's going to be 45. So 64 is equal to 45 minus 36 times the cosine of x. Now I'm solving for x here. The next thing I'm going to do to solve for x is subtract 45 on both sides. So I'm going to subtract 45 and subtract 45. So 64 minus 45 gives me 19. 19 is equal to negative 36 times the cosine of x. I'm still solving for x here. I need to get rid of the negative 36, which is being multiplied to the cosine. So I'm going to divide both sides by negative 36. So 19 divided by negative 36 is negative 0.527 repeating, and that's equal to the cosine of x. In order to find out what x is, I have to inverse cosine both sides. So I'm going to inverse cosine of negative 0.527, and that's going to be the inverse cosine of the cosine of x. Of course, the inverse cosine and the cosine will cancel over there. And in my calculator, I take the inverse cosine of negative 0.527, and that is equal to 58.14. That's what x is, 58.14. That's our final answer. So in this problem, we used the exact same formula, the same law of cosines, but instead of solving for a missing side length, we solved to find a missing angle measure. But we used the same formula to do that. Again, make sure that you have this problem written down in your notes, because we're going to submit our notes on Canvas. If you didn't have enough time to write it down yet, go ahead and do that now. We're going to move on to the last little piece of this video, which is you trying one more problem on your own. And the problem that you're going to try next is the same thing that we just did together. Here's the problem for you to try on your own. In this problem, you're trying to solve and find out what x is equal to. This is the last problem of the video. Please pause the video, take as much time as you need to solve the problem, and after you're finished, then I'll go over the answer. And the answer is 62.9. If you got the answer, congratulations, you can go ahead and end the video. If you did not get the answer, let's talk about how I got it. In order to get this answer, I am using the law of cosines. The law of cosines says that you have a certain side length and you square it, and that's going to equal the square of the other two sides added together minus 2 times the other two sides times the cosine of the angle that's across from the first side. So the first thing is to make sure that you're substituting in the right pieces of information into the formula. This is what it should look like. The 1.9 does have to be here on the left. That's important. And the reason that the 1.9 has to be there on the left is because it's across from the x. In the cosine formula, in the law of cosine formula, the angle measure and the side length that are across from each other are always going to go right here and right here in the formula. Then the other two random sides, those are going to go here and here. So that first step is just making sure that you have substituted the right numbers into the right places in the formula. Once you've done that, go ahead and look at the way I've highlighted this. I highlighted that on purpose to show you how I was simplifying everything. So the green numbers that simplified to be 6.1, the blue numbers simplified to be 5.46 times the cosine of x, and then the orange number 1.9 squared simplified to be 3.61. After you do that first step and you simplify a little bit there, then you subtract 6.1 on both sides. Then you divide both sides by negative 5.46. Then you do the inverse cosine of both sides, and that's how you get the final answer of 62.9. All right, that is the end of this video. You have just learned how to do the law of cosines.